Okay, focus. And we start recording that. If you want to know further how to self-invest, come and talk to me, okay? I will tell you what to use. Right. So we have isolated the problem. So the only thing that we have not considered is we have not considered is A. Okay, we have not drawn A yet for now. Okay, for now we are not drawn A yet. So the center over here will be my O. Okay, I'm going to call this my O. And over here, at this point over here, is my S. Okay, that's my point S. So now we are going to consider the rigid body. And we are going to rigid body on the sun. Okay. So we know that Vs is equal to Vo plus by omega S. You can call it omega SO or just S, I'm fine. And cross R, okay, S from O. Okay. So we know that at point O, right, it's a boundary condition again where the velocity at the center, right, velocity OI is equal to velocity OJ, and this is equal to 0. It's fixed at the center. So we know that this will be equal to velocity of the sun, 0. And then we know that omega S, are we given omega S? 5. Okay. And it's going in a anti-clockwise direction, plus 5K cross O to point S. Okay, again, we were asked to analyze at this instance. So at that instant over there, our radius is 0.08 J. So from here, we know that Vs is equal to 5 multiplied by 0.08. It's equal to 0.4. So K cross, now this is J. K cross J is negative. You have all positive, so it's minus, okay, 0.4. And now at 0.4, 0.4 I, okay, meters per second. Okay. Now, what it means over here in the I direction, right? What it means over here, this direction is correct, right? As it should be, okay? Now, the next thing that we are going to do now is we are going to focus on the rigid body, which is our planet. Okay. And I'm going to take the planet out because the planet can be really abstract. Okay. And I'll tell you why. So this is our center over here. Okay. And I will call the center P. And we are aware that we have a what? We have a velocity over here. And this velocity over here, we know that Vs, right, is equal to minus 0.4 I. And we know at this point over here, right, VR is equal to 0. Because at the top point over here, at this point over here, is connected to a what? Ring gear. Okay. Now, VP, at point P, it will move a certain direction. Which direction? I don't know. Okay. So we are going to assume this is our VP direction. So this is our assume. Again, don't worry. Later on, it will tell if it's, once we go into our component analysis, if it's positive, means it's correct. If it's negative, means it's wrong. Okay. Or the direction is flip over. Okay. So the first equation that we are going to focus on. Okay, so now we are focusing just on the what? On the planet. Okay, so we can determine our angular velocity of our planet. So we are going to write VP, velocity of the planet, is equal to Vs plus by omega p. And we did assume omega p direction that we are very comfortable, right? So we assume the omega p is going in this direction. Okay, cross R P on point S. Okay. So from here, we can write out our VP. And our VP, we know that is only in the I direction. Okay. So VP is equal to Vs is minus 0.4 I plus is going in the clockwise minus omega pk cross R S. So S is down here, P is up there, and the radius of the gear is what? 0.4 or 40 millimeters, which is equal to, so it's on P 0.04 J. Okay. So over here, we write out P is equal to minus 0.4 I. K cross J, K cross J, K cross J is negative, negative would be positive. Okay, so there's another negative, so it would be positive 0.04 omega P, and then this is our I. Okay. So as you can see, we only, so this I'm going to call our equation 1. Unfortunately, what we see down here, right? We have one equation and two unknown. Okay. Then the next thing that we can do, right? So what we did earlier, I'm going to draw a different. What we did is we analyze this point over here, and then we analyze this point over here. Okay. So we need another set of equation, right? And we can, I'm going to write out this equation and you have to tell me, okay, is this valid or not? Okay, so you have to, I'm going to squeeze this up. Okay, oh, this belongs to, okay, and you're going to tell me, is this valid or not? Okay, if I write this, Vs is equal to VR plus by omega P cross R S over R. Is this equation valid? Yes, why, no, why. You can call a friend or 50-50. Yes. What is a rigid body? Points what are a rigid body? You're right. Okay, because points where the triangle is, I'm going to call this S, okay? S, P, and R, okay, where I call this point R, they are on the what? Same gear. We clear. So when that's the case, this equation can be written. We clear. Well done, okay? Remember what I told you guys yesterday, right? Only on a rigid body, then you can form an equation like this, okay? So from here, well done. We have a minus 0.4i. Thank goodness VR is equal to what? 0. Okay. Then we plus omega p is minus because it's going in an anti-clockwise direction. Cross S, okay, point S. Now you have to be careful. Now, so the point of reference is R over here. So it's minus, what is the radius? Sorry, people, my bad. 0.04, so it's 0.08. Let me, I'm pretty sure after class someone asked me, where did that come from? You all can see, right? Yeah, right, Egypt. So we can see that the ring gear, the planet gear has a radius of what? 40 microns, right? So the distance from here to here is what? 40 millimeters. So the distance from here to here is also 40 millimeters. So that's how you get 0.08. So from here, we get minus 0.4i, and this will be equal to, so this is j, sorry. So k cross j, k cross j, my j, k cross j is minus, 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 and another minus. So you get minus 0.08 omega p, and this will be our I. Okay. So based on the I component, right, you have minus 0.4 is equal to minus 0.08 omega p. So omega p is equal to 0.4 divided by 0.08, 0.4. You get what? 5 radians per second. And it's what? Positive. Positive meaning that omega p direction is correct. We knew it was correct in the first place. Yes or no? Right? We were very sure it was correct in the first place. Okay. So now, knowing all those now, okay, we are going to use, okay, we are going to use equation number 1. Okay, we're going to use equation number 1. Okay. Now I'm going to get equation number 1. I'm going to bring over. Okay. And we know that our omega p, right, and I'm going to get the diagram. over here across. Bear with me. I do apologize. I don't mean to